Okay, this is an introduction to polynomials. It's chapter 9. Will be the last chapter that we cover before we get into our statistics unit. It begins on page 475. No, 495, excuse me. On your note sheet, it says polynomial introduction. Polynomials are monomials or the sum or difference or two or more monomials. Okay? So we're going to talk about the main three types of polynomials. You see monomial, binomial, and trinomial. You can use your prefix clues to figure out what these mean. So to fill in the chart, we're going to look at a monomial. Monomial, the prefix mono is 1. So a monomial is one term. Just one term. So if you can think of an example of one term, 7 is one term, 4x is one term, 3a cubed is one term. See if you can come up with one more. Binomial. Binomial, using our prefix clues, bi is going to mean 2 terms. Okay, so if you think of something that has 2 terms, maybe it's x plus 7. That's 2 monomials together, x and 7. Or maybe it's 3x squared plus x. That is a binomial. So if you can come up with one more. Lastly, we have a trinomial. Tri, using your prefix clues, you can figure that it is 3 terms. Like x squared plus x minus 4. 17a plus a cubed plus a squared. 3 different terms. See if you can come up with one more. Moving on to the degree of a polynomial. When you look at the degrees of a polynomial, it is the variable that is the same degree as the monomial with the greatest exponent. In other words, they're having the same variable part. Okay? So this particular item right here, is this a binomial, monomial, or trinomial? This is a trinomial because it has 3 parts. 3x to the 4th, 5x squared, and 7. So when we look at each of those monomials, what is the highest degree of those? In other words, what is the highest exponent that we have here? It is a 4. So this would be called a 4th degree polynomial. Okay. If you want to look at a couple of other ones, you can look at 3y minus 4 minus y cubed. Okay, so my monomials are 3y, 4, and y cubed. What's the highest degree there? Cubed. So it's a 3rd degree. Okay. What about classifying polynomials? In other words, we need to know the type and the degree. So is it a monomial, binomial, trinomial? And what is its degree? Okay? 6x squared, 7, 9x to the 4th. 3 different terms. Since it's 3 different terms, it's called a trinomial. Okay, what is the highest degree that we have? It is a 4. So it's a 4th degree trinomial. What about this one? 8 plus 7b and minus 11b. A little bit of a problem here. We have two variables, or two terms, that have the same variable degree. So we probably need to combine like terms here before we can determine what degree it is. Because if I would say, as it is now, it looks like a trinomial to me. But I can simplify 7b minus 11b. What does that become? Negative 4b. So 8 minus 4b is what my answer is. Now that totally changes it. It doesn't change my degree. It's a first degree. A first degree what though? 8 is a term and 4b is a term. So it is a first degree binomial. Okay? Any questions about those? Good. Let's move on to then adding, subtracting, and multiplying. Whoops, I don't need to extend page. I need to go to a new page. And I'm completely cooperate. Adding polynomials. Adding, subtracting polynomials, you can set it up one or two ways. You can keep it horizontally, or you can line them up like we do on a system. I prefer to line them up. So I have 4x squared plus 6x plus 7. And when I say line them up, I want to make sure that my terms line up together. In other words, if I have another x squared, it should be under my 4x squared. And usually when we write polynomials, we write them from the highest degree down to the lowest degree. So I have 2x squared minus 9x plus 1. And I'm adding these two polynomials, so I'm going to add these two, just like I do my system. And now I add my coefficients, because my variable parts are the same. So 4 plus 2 is 6, keep the variable part the same, x squared. 6 plus negative 9, negative 3, keep my variable part the same, x. 7 plus 1 is 8. 6x squared minus 3x plus 8. Adding polynomials. Subtracting polynomials. Same thing. Line them up. You can keep it horizontal like this. One thing to remember is this is almost like this is negative 1, because it's going to affect everything inside. I'm going to set it up horizontally again. I mean vertically. B cubed plus 6v squared minus b minus 9v cubed minus 7v squared plus 3v. Same thing like we did with our systems. No coefficient here. I can put a 1. 1 minus 9, negative 8, v cubed. 6 minus negative 7. Minus negative 7 becomes plus 7. 6 plus 7 is 13, v squared. Negative 1v minus 3, negative 4v. Subtracting polynomials. We will do some practice with that. Multiplying polynomials. Just like the distributive property, 4b becomes my distributor and goes to each term inside the parentheses. This is actually in the next lesson, so your examples for this are on page 500. 4b times 5b squared. Well, multiply your coefficients first. 4 times 5 is 20. B times b squared is b to the third. plus 4 times 1, 4. B times B squared, B cubed, plus 4 times 6, 24. No B, B times 1 is B. Do I need to combine some like terms here? Absolutely. 20b cubed plus 4b cubed, right? That becomes 24b cubed plus 24b. Next time we'll talk about factoring out and finding factors. But for today, finish up with guided practice 10, 16, 20, 24, 34, and number 8 on 501. When you finish that, you can get your assignment from exponential growth and decay.